Hello everyone and welcome to the another exciting lab session in CSE 126 graphics and visual computing. Today we will learn how to draw on images using OpenCV. So this is a powerful feature for annotation, visualization, object marking, and others. So by the end of this lab, you will be able to create black canvas using the NumPy library and draw basic shapes like lines, rectangles, circles, and text. And also understand how OpenCV treats image coordinates and colors. Okay, so let's start by importing the necessary libraries here. So we have the import CV2 for OpenCV, import NumPy as NP, and we utilize the matplotlib. We will just import just the pyplot as PLT in this case, and we will have this define helper function to display images using matplotlib live in this case. Okay, so this function helps us to render image with consistent width and height, or the aspect ratio in this case. Okay, so as you can see here, this is a usual helper function for display images from our previous laboratory activities. Okay, so to start, no, um, or before we draw, we need a canvas. So let us use NumPy to create black image. So what we have here is we create a black image using NumPy to create a array of black. So what we have here is image is equal to np.zeros, 5112, 5112, and 3. Then we have np dot UN8 in this case. So, this creates 512 by 512 with three channels. R, G, and B are all set to zeros in this case. Okay? And what else? Okay. For grayscale, just remove the third uh, parameter here. So what we have here is just this size. Okay. So let's display it using our helper function. So black canvas and the grayscale. So in this case, we have three channels here and one channel grayscale here. So as you can see, we have uh, a black canvas for color and grayscale. Okay, so now let's draw a line across our canvas. So we use the CV2 dot line. In this case, we have our target image, which is this one image. Then we have here are the coordinates. As you can see here, we have a coordinates here, and this one is the color of the line. So since we use, or since the color order of the channels for OpenCV is in VGR, so that's why it is like this: 255, 127. So blue, B is 255, G is 127, and red is 0. That's why it is somewhat the blue is high here. As you can see, it's like a sky blue in this case. So what else here? And this one is the thickness. Okay, so well, we have these parameters here. So this is the target image, the starting coordinate, the ending coordinate, and the color of our line and the thickness of our line. Then we utilize our helper functions to display an image. So we have the title and the target image. So right now, what we have here is okay. So right now, the image and data recently, in this case here, is altered. And what we have here is we have a line here. So what we have here is a line from 00 to uh, 511 in this case. Okay, so 511 by 511. Okay, so what we have a line, diagonal line in this case. Okay, next is drawing rectangles. So what we have here is we have this um, a function here, cv2 dot rectangle, the target image. Next is the starting vertex and the opposite vertex here. So starting and the opposite. So the color and the next is the thickness. So since the image recently has been altered because we have a line already, so we recreate or reassign a new um, a new image to this container here or this variable. So we just uh, create a black canvas again. Then right now, as you can see here, we utilize this one. Then what we have here is we have a starting vertex of 100 and 100 here. So as you can see, 100 and 100. So this is the starting vertex here. So obviously, what will be the opposite vertex would be this one. So 300 by 500. So as you can see, this is 300 by what? 300 by 250 in this case. So here, 250. So this is the opposite side. Then we have this color here. So blue is 1 to 7, green is 50, and red is 1 to 7. That's this one will become a pink triangle here. And we have a thickness of 10. So this is the rectangle image here, output. So we utilize the helper function for to display images. Okay. So what else? Okay. So now let's draw some circles. So to add a circle, just use the cv2 dot circle. So this is okay from spelling here. So you should well, let me rewrite this one. Okay, later on. So this should be circle here. So this is a typo. And then so cv2 dot circle image target image. Next is the center of the circle. What will be the radius? And next would be the color and the fill. So if it is negative, so it means that it should be filled. Okay, inside inside the circle. Okay, so right now, so what we have here is we have a target. Well, since the image is already have a pink rectangle, that's why we need to re-update the image container here or the variable to a black canvas again. Then what we have here is we have the cv2 that circle, we have the target image here. Then what will be the center? So the center should be on the 350 by 350 and 350. So this is the 350 somewhat here. Okay, and here. Okay, somewhat here. Then we have a radius of 100 here. So we have a radius of 100 here. Then we have what what we have here is a circle of blue is 15, green is 150, and red is 50. So somewhat it is green or green circle here. Then what we have here is it is in field, so field inside the circle. Okay, so we have a field circle here. So we have with a center of 350 by 350, 350, the x and y here, and we have a radius of 100. Okay, for the next one is for polygons. So what we have here is we will utilize the use of the polyline function here. So we have the cv2 dot polylines image the points or the vertices of polygon. So well, why we use polylines? So there's a parameter here that if you want to connect the first and the last points. So well, once the last points and the last point and the first point will be connected, it will become a polygon. If not, or if it is false, it will be a polyline. So that's why we use polylines here because it has a parameter here that there's a function here that um, if you want to connect the first and last point, so well, it will become a polygon. Then if not or false, so it will become just a polyline. So here is the color and the thickness. Okay, for example, here we have a black canvas here. Then we have 4 points here. So we have an um wait for a while. Okay, so yes, we have 4 points here, and what else? It is a array with 4 coordinate points. Okay, and what else? Um, okay, so well, for this one, I will just discuss this later on. So this one is just to reshape the points here, since the requirement here is a 3D array. So right now we have a 2D array here. So that's why we need to reshape this one. So for just a simplicity, for a simple explanation, this one, so it will just have to retain the original size, and then we just have to um so in case here since we have four values here, so we set this um well here NumPy will automatically figure out how many sets of points there are in this array. So in this case, we have four. So this one will retain the four values here, and one here is it will add a middle dimension so that it will be wrapped in another bracket. So I will just demo this afterwards. And this number two here, so well, each point where it's since it is have a set of 4 points here, so each of those set of points which is four has two values x and y. So later on, I will just have to explain it to you briefly. Okay. And next here is, well, since we have CV2, the polylines here, the targeted canvas, the points here, though it is reshaped into a 3D array here because it is a 2D array. So I'll just explain it later why it becomes a 3D array. So we toggle this one to true. Then we have a red line and a thickness of 3. So as you can see, we have this one. So this is the first coordinate, the second coordinate here, 40, 50. Okay, good. So 90, 200. Okay, 200, 90. And the last one is 50, 500. Okay, so this is the explanation on why um, why it becomes 3D array here. So okay, first is okay, we have this 4 points here, and what else? Okay, so if we use that shape, so we have four values or a four set of points with two values of each point. That's what it means in this shape here. So we have four values or four set of array with two values in each array in this case. Okay, so we have four row. So we have four rows in this case, four rows, and obviously two columns, the x and y. Okay, so we have the shape of four rows and two columns. Okay, if we have to display it properly, so it should be like this one. Okay, okay. So the shape here is four rows and two columns. Okay, so let me fix this one. Okay, all right. So what we have here is we have a shape of the array here is four rows and two columns. Okay, so since the polylines here it requires a 3D array here, so we need to reshape um the this array here, since this is a 2D array in this case. So as you can see, what we have here is we have negative 1, 1 and 2. So what does this negative 1 here is this negative 1 um, automatically figure out how many set of points there are in this array. So in this case, we have four sets. One, two, three, four. Okay. So since it is four, so it will add in this tuple here. Next, this one here, so it will add a middle dimension so that each point is wrapped in another bracket. We will check this later on, no? Why it will be wrapped into a certain bracket. So this one actually. Then 2 here is it determines that there are two values on each point here. So as you can see here, we have 2 points here. So to reshape this one, so it retains the number of sets of arrays here. One, two, three, four. Then it will be wrapped into a one-dimensional or one dimension here. So as you can see, we have one bracket here and this one. So right now, as you can check the shape on this one, so it is now a 3D array here. So it is wrapped into a one bracket, one dimension. So we have it retains the shape of the previous data here. So as you can see, it is wrapped into another dimension here. So example, this is the um, one dimensional here, one here. So this is the one dimension here. So it wraps the first array here, set of points here. So next is this one, and this one, and this one. And it will ends with another one bracket here. So it will contains all. So obviously here is just adding the another bracket here in this case. Okay, so that it will be it will satisfy the requirement for the polylines. It is should be a three-dimensional array. Okay, so right now if you just have to input this one, it will raise an error in this case. So if if I will not use this one, okay, let's rerun this one. Okay, I think um we already run the okay, let's say this is the points. Okay, so what happened here is okay, the shape. Okay, so we have the problem with the shape of uh, the point. That's why we need to reshape it. Okay, so right now, well, explains why we need to um, reshape the data here, because this is a 2D array here, and this one is uh, just we need to retain the data here, and we just wrap each sets into one dimension. That's why it will become a three-dimensional in this case. Okay, so okay, right now let's move on to the text. So okay, lastly, this is the another function here, put text. So this is the method here, cv2 that put text, the target image, what will be the text to be displayed. This is the where will you put the starting point to display the text. Then what will be the font size, the color, and the thickness. Okay, for example here, well, this is the available fonts for the OpenCV. So this is the Hershey font in this case. So what we have here is we have a black canvas with 100 by 100 with 3 dimensions here, and this is our output string, or this is will be displayed to the OpenCV canvas here, and we put the text in the image using the text to display here and the coordinates where you will uh, input the data. So as you can see here, so that will be here. So 115 and 155 by 290. So somewhat here in this case. So this is the coordinate. Then it will be simply put the text here, and we have the thickness here is 4. Okay, then we have the font size 3 in this case, and the color of the text. Okay, so this is where you add an image here in this case in OpenCV. So well, this one is a very useful one if regards to you want to you put um, text on a video in this case. So um, just keep it in mind that this is how will you utilize this method here. So you have the target image, what will be the text to be displayed, what will be the starting point where the image will be displayed, and what will be the font size, color, and thickness. Okay. In the meantime, so this is for the laboratory for um, the laboratory activity for drawing on images. Okay, so thank you for listening.